Here we are, guys. Example 3, parts E and F. This again is the normal approximation to the binomial distribution. Ooh, I love those fancy math words. All right, so we've got 80 people that we've surveyed. We've established all these things. Please watch these in sequence. It will make more sense, I think, if you do so. All right, so of those 80 people, what's the probability that between 10 and 18 of them text while driving? So you got this range of numbers from 0 to 80, and we're talking about between 10 and 18. All right, between 10 and 18. Now, we can agree to disagree if you want, but to a mathematician, the word between means strictly between. The point being, it does not include those numbers themselves. So if you're going to be between 10 and 18, that's actually going to be these numbers from 11 to 17. Those are the numbers that are mathematically between 10 and 18. 11, 12, 13, 14, 15, 16, 17. Between. The point being, in the math class, if you say between, you're not including those endpoints themselves. And that's very important when it comes to correcting for continuity later on. So, the way you would write that as a probability statement would be 10, 18, and x is between them. Notice there are not equal to. That's important. So there we go. Now, we've established in previous steps or previous parts to this question that it is appropriate to use a bell curve here, and the fact that the mean is 16. All right, n times p, all that. Use that information. Keep recycling. Okay, now, the crucial step, in my opinion, and I would say most people who teach this would say the same thing, correcting for continuity. So when you draw a number line to represent the variable x, and you put 10 and 18 on there, it is imperative that you understand, because of the word between, that a mathematician would say, we're not including the 10 and the 18. We're leaving them out. Hollow. That's what you learned back in college algebra, was the symbol on a number line for exclusion of a number. Okay? I remember it well. So, that impacts the correction for continuity step here significantly. So let's talk about that. Let's talk about the 10. We can either go below the 10 by 0.5 or above it. I would hope you'd understand that if we want to be between, we want to go in the direction that would be between. And so we'd want to add 0.5 to that one, and that would give us 10.5. We want to be between. We want to come, what's the point of this? Between. Inward is what's going to happen. So that one will go upward to the right of 10, above 10. And then 18, how do we, which way to be between? Between, this way, in between. So in this, and so 18 minus 0.5 is 17.5. And there we go. Those are the two values of x after they've been corrected for continuity. So in one case, we're actually going above it, and the other one, we're going below it. But in both cases, what are we doing? We're going between. We're coming inward, all right? So that would be the deal on that. And so, you know, one of them is to the left and one of them is to the right. I don't want you to memorize rules. I just want you to look at the picture here. But anyway. One of them went to the right and the other one went to the left. You know, it just depends. Between. I don't know what else to do there. Okay, so 10.5 is below 16, so it would be on the lower half of the bell curve, and 17.5 is above 16. So we're talking about, oh, this is going to be combining two middle slivers, isn't it? I'm trying to review all those things that we did on previous episodes of college algebra, or of statistics, pardon me. So, I'm going to be recording college algebra a little bit later today, so go to YouTube and watch that one if you want, okay? Are you guys binge watching math flicks here? Whew, awesome. Okay, so now we're going to draw our standard normal bell curve with 0 in the middle and we've got one number below it, we've got another one above it. We're going to talk about that region in between. Oh, this is so assignment 17. Oh, I remember it well. All right, so we're going to transition into Z, and we're going to standardize both of those scores. So in terms of the 10.5, that's going to be 10.5 minus 16, the mean, mu, over sigma, this crazy 3.5777 number that is giving every one of us a headache. All right. So anyway, 10.5 minus 16, I'll go ahead and do all the steps here. 10.5 minus 16, I'm tempted to go, oh, we've done this before, just go do this. But, oh well, we're here, kind of. Math party. Looks like that one standardizes to negative 1.537. That'll make that a 4. Negative 1.54 on that lower one. Okay. Race me if you want, or hit pause and work it before I do and see if you get the same thing. You're probably able to beat me, but this would be 17.5 minus 16, x minus mu over sigma. All right, so that would be 1.5 divided by 3.5777708, blah, blah, blah. Looks like that's 0.419, that'd be a 2, 0.42. Remember, z-scores get rounded to 2 places because our friend, the table, only takes z-scores out to 2 places. And speaking of our friend, the table, we're ready, aren't we? Okay. So we've got a standard normal bell curve. Table time. So 1.54 on that beautiful table. 1.54 produces a middle sliver of 0.4382. Table will always give middle sliver. Look up z-score. It give middle sliver from here to middle. All right, 0.42. This table, by the way, not all tables. 0.42 is 0.1628 middle sliver, 0.1628. And as we practiced extensively on assignment 16, I hope this particular picture would conjure up to us the idea that we need to add those 2 middle slivers, don't we? So, 0.4382 plus 0.1628, carry the 1, carry the 1, carry the 1. I hope I did all that right. 0.6010, no, I messed up. What happened here? I made an error somewhere in my calculations. This is screwing me up, doggone it. What happened here? I got different answers on my slide. Dang it! I don't know that I'm going to re-record the whole deal. The answer should be, oh yeah, it's there, 0.6010. Never mind, I'm good. I was looking at the wrong answer. Yay! I screwed up by screwing up. 2 negatives make a positive, I guess. Yeah, that's it. Yay. Woo! I was looking at the wrong answer. Table time. All right, now, I miss having you here to point out when I mess up. Thankfully, I didn't there. All right, now let's go ahead and do part F here because it's very similar and we can make some modifications to this picture. So again, hit pause if you need to. Look at part E, get caught up. Let's move on. All right, what happens here? What would a mathematician say? Sounds like a joke, right? What would a mathematician say? I have some math jokes, but yeah, a few. Let's move on though. Part F. What would a mathematician say if they wanted you to include the numbers, the 10 and the 18? They would say between 10 and 18, comma, inclusive! Include them. All right? So what's happening over here is you're going to expand this to include the 10 and the 18. To me, that's between 10 and 18, inclusive, including. All right? How's that change things? Let's get rid of the answer from the last one. Well, look, what that does to our number line here is now we're going to include them. symbolically, don't we say, okay, this time it's okay to equal the 10. It's okay to equal the 18. Oh, it's going to solidify them. Yeah, I like the visual. There's other visuals out there. I don't have time to show you 20 different ways to think it through. You're stuck with Mr. Soap Dish, the way he likes to see things, I don't know. But I hope in this case you'd understand that to keep the 10 in the discussion, we'd have to come below the 10 by 0.5, and therefore this lower number now becomes 10 minus 0.5, 9.5. Don't add 5. Don't subtract 5. It's 0.5. All right, and then on the upper end of it, wouldn't we want to go upward by 0.5 to 18.5? Doesn't this range keep the two numbers in there? Doesn't it keep the 10 and the 18 in the discussion? So there you go. That's the modification that needs to be made. And so now on our picture, wasn't this smart of me to just modify these and be lazy? Okay. But now we're looking at that area between 9.5 and 18.5, bell curve, 16 in the middle, as discussed earlier. And so obviously that's going to change the standardization of these, which changes the middle slivers and changes everything, doesn't it? So now we're doing 9.5 minus mu over sigma to get that z-score. You know, this again is back to what we've seen before. This is assignment 17 going on. And that z-score becomes negative 1.816. So that would round to a 2, negative 1.82. There's a new z-score in town, right? And then on the upper end of it, this changed to 18.5 rather than the 17.5 on the last example. And so that standardized score, I really should have saved that standard deviation in my calculator and this kind of thing. 0.698, 0.70. Make sure you use the traditional rules of rounding on these z-scores and make sure you take them out to 2 decimal places. So much like the one just before, this is going to be a combination of 2 middle slivers. We look up the 1.82. Oh yeah, this is assignment 16, isn't it? Yeah, it is. Good observation. 1.82 is 0.4656. This is where I'm nervous. I hope we did this right. Everybody cross your fingers, would you? 0.70 is 0.2580, middle sliver. And we'll combine those 2 middle slivers to get that shaded region, as practiced, as demonstrated on assignment 16. All right, we're getting an assignment 16 booster shot here. So, let's pull this up here. 0.4656 middle sliver plus 0.2580 middle sliver. 6, 13, 12, 7. I'm adding like I was taught in grade school. I hope that came out right. I'm nervous. Let's look at the answer. Yay! I want to remind you guys, you also have those practice problems that you could do on your own, where you can work them and then check the answer. And when you get it right, you can go, yay! All right, anyway, let's go Royals. Let's move on to the next example.